So I want to make sure we get through a few things today. First, we're going to look at a hip roof, but not like we did yesterday with finding the length of the common hip and the difference in the jacks. We're just going to look at the flat out hip roof as far as finding the angles and the area of the roof. So there's our hip roof. We're going to give you a 28-foot span, 48-foot run, 9/12 slope on the main roof, and a 13/12 slope on the hip portion of the roof. So as always, we're going to start out with the common rafter. And we're going to do the common rafter right here at the point where it transitions from the ridge to the hip. So what we're looking at, not just the whole setup, we're just going to look at this portion right here. So we'll draw out our full triangle. We know this has a span of 28 feet and a slope of 9/12 on the common portion. We're looking for this height. Find that height. 9/12 equals h over the run here will be 14 feet. So we cross multiply and divide to get that. 9 times 14 divided by 12 is a 10.5 foot height. That, of course, will allow us to find this common rafter length, which will be the square root of 14 squared plus the 10.5 squared. Giving us 17.5 feet. So that is this length right here, 17.5 feet. Now from that, I should have specified, of course, what we're looking for here. We're looking for an angle here of alpha, an angle here of theta. We're looking for the ridge length D, and of course the roof area. So from that, we can't find anything quite yet. We need to now transition over to the hip roof side. So what we're going to be looking at is this triangle right here that, I should draw that a little bit different, that defines the hip. What's really the only part that's visible to us is going to be that portion there, but we're going to draw it like this. Now we do not know this length, which would be the setback. Up here, that would be this length right here, the setback. All we know about this is that the height has to be the same as the height of the common, so it has to be 10 foot, or 10.5 feet. And we do know the slope is 13/12. So I know that 13 over 12 has to equal 10.5 over, I'm going to call that S for my setback. And again, we can cross multiply and divide. 12 times 10.5 divided by 13 gives us 9.69, we'll call it. So the setback here is 9.69 feet. Setback over here will be the same, 9.69 feet. So we can now find D. We take that full length of 48. We subtract 9.69 from that twice. We get that D is 28.62 feet. It's a ridge. Going back down to here, now we can find this here length of that main hip jack as the square root of 9.69 squared plus 10.5 squared. 9.69 squared plus 10.5 squared gives us 14.29 feet. This is 14.29 feet. We now have all the information we need for our angles and our area. Let's start off with this triangle over here. We know this bottom is 28 feet, and this length here, obviously not drawn to scale, is 14.29 feet. I'm going to find this angle here. So I'm going to cut this part off. This is a right angle. That'll be 14 feet. That angle here is the inverse tangent of 14, the opposite side over the adjacent side of 14.29. This obviously would be just slightly less than 45 degrees because those two numbers are almost equal. So let's make sure I am set into degree mode before I try this. Second tangent of 14 divided by 14.29 gives us 44.41 degrees. Which means that theta, which is the whole thing, is 88.82 degrees. Not theta, that is actually alpha right here. Alpha equals 88.82 degrees. We can find the area of that piece. Simply going to be the 28 times the height of 14.29 divided by 2. Now there's one on the other end that's exactly the same, so we'll multiply that area by 2. 28 times 14.29 divided by 2 times 2. Obviously, the dividing by 2 and multiplying by 2 cancels out, but I'm just going to do it to perform for completeness. That's 400.12 square feet from those two roof sections. Next, we're going to look at finding the angle theta here. Finding the angle theta, we're looking at this piece here. This setback is 9.69 feet. This length of the common is 17.5 feet. And I've divided theta here into two angles. I have a right angle, the 90 degrees, and then this angle here, which will be the inverse tangent of the 9.69. That's the opposite side over the adjacent side is 17.5. Here's 28.97 degrees. So if I add those two angles together, I get theta is the full angle there, which is 118.97 degrees. So I found my angles, I found my ridge, my D. Now I just need to finish off the area by finding the area of that trapezoid. When I finish that trapezoid off, this is 48 feet all the way on bottom. The top is 28.62 feet. The area of a trapezoid is the average of the bases. That's the 28.62 plus the 48 divided by 2 times that height, which is 17.5 feet. Then, of course, times 2 because there's one on the other side of the roof as well. So 28.62 plus 48. Make sure you hit equals before you divide by 2 there. The average length is 38.31 times that height of 17.5, and then times 2 because of the other side. We get 1340.85 square feet. We add those two areas, 1740.97 square feet of roof area. So you can see once we start breaking it down, finding the length of those common rafters and longest jacks and the setback, the rest of it falls in relatively simply. So the next type of problem I want to do is one the dormer in it. Nicer here. So let's say we have a 28-foot span across here. Let's give this an 8/12 slope on all roofs. We'll keep the same slope on both roofs. We're going to give this 6 feet coming out here, be 6 feet. This across here will be 16 feet. So again, obviously not drawn to scale. And our total ridge is 36 feet. And what I would like to find here, I'd like to find L, which is the length of this ridge. I would like to find theta, which is this angle here. And I'd like to find the roof area. So we'll start out by finding the area of the main portion of the roof. And to do that, we're looking at this common rafter again, which is just this length here. So we'll start out looking at that triangle where this is a 28-foot span and there's an 8/12 slope. We have to find the height. Obviously going to be a 14-foot run here. So 8/12 equals h over 14. So we're going to cross, multiply, and divide. 8 times 14 divided by 12. We get h is 9 1/3 feet. So then to find the length of that common rafter, it's the square root of 9 1/3 squared plus the 14 squared. Giving us 16.826 feet. So that's this here, 16.826. We're going to multiply that by the 36 feet here. And then times 2 because there's a plane on the other side. So for roof area right now, we've got that 1,211.47 feet. Square feet. Now there's a piece of this that has to be cut out because the part that this dormer sits on needs to be cut out. It's not going to be roofed, so that's going to be taken out of that total area. Then we'll add the dormer to it eventually as well. So let's look at finding that area that's missing. If we're looking at that side of the roof, there's a triangle like this that's missing out of it because the dormer is covering it. We know the width of that triangle is 16 feet because that's the width of the dormer, but we need to know this height. To find that height, we look at this from the end of the roof again. We know that both roofs are an 8/12 slope, so I need to find this height here, which is just going to be the height on the end over here. So let me draw out that piece. A little bit straighter. This is 16 feet, also an 8/12 slope. We're going to find this height now on an 8-foot run. So it's 8/12 equals h over 8. So we cross multiply and divide. 8 times 8 divided by 12 is 5 1/3 feet. So that height here is 5 1/3 feet, 5.33333. Why is that important? Well, because we can use that now to find this here, the setback. That's 5.33 over, I'll call it S. This is an 8/12 slope on this roof as well. If I cross multiply and divide there, 5.33 times 12 divided by 8 S ends up being 8 feet. So that's 8 feet there. This actually gives us our wedge length already now, because this is 8 feet, and this distance here was the 6 feet that stuck out. So that length L, 8 plus 6 is 14 feet. We still need to find this height of that triangle cut out of the roof. That's going to be simply this length here. So we're going to do that, the square root of 8 squared plus 5 1/3 squared. Giving us 9.1 or 9.615 feet. This height here is 9.615 feet. So the area that takes out is 16 by 9.615 over 2. So 76.92 feet is what's removed there. So if I subtract that out here to get a running total, I have 5, 5, 4, 3, so 1,134.55 square feet so far. Now I need to find the area of that dormer, and in the process, hopefully we'll find theta. Actually, I already have what I need to find the area of the dormer. If I look at this side here, this is 14 feet, this is 6 feet. This is the slant. That would be this slant here, where I already did that same calculation. That length is going to be the square root of 8 squared plus 5 1/3 squared. Comes out to be 9.615 feet. Because the slopes are the same on these two roofs, the height of this piece that's cut out of the main roof for the dormer is the same as the slope, the common rafter on the dormer. So this is 9.615. So that area is going to be 6 plus 14 over 2 times 9.615. And of course times 2 because there's going to be 2 of those. So 6 plus 14, remember here, always to hit equals before you divide by 2. 10 is that average length, which makes sense. Times 9.615 times 2, because there's 2 of them, gives us 192.3 square feet. So I add these together. Excuse me. At 1,326.85 square feet. It's my roof area. Finding theta. Well, we're back to this drawing here. If I put this in like this, that's a right angle. That's 90 degrees. This angle here will be the inverse tangent. That opposite side is 8 feet, actually, not 6. So it'll be the inverse tangent of 8 over that 9.615, which is this length. Inverse tangent of 8 divided by 9.615 gives us 39.76 degrees here. Plus the 90 for that right angle. So 129.76 degrees is our angle theta. Any questions on that one? Okay, so time to look at an example similar to one that was on our quiz. drawing is horrible today for some reason. So we have this roof that we're looking at, and we're going to find roof area. We're starting off with a 612 slope. This piece down here is 44 feet. I did not give you the span. You have to fill in that span of 36 feet. 10-foot height on the long side of that chimney, and a 30-inch diameter on the chimney. First, let's talk about that chimney. More specifically, the hole that it cuts into the roof. That hole that it cuts into the roof has two dimensions. This dimension across here, which I'll call dimension B, that's just the 30 inches of the chimney. That's not going to be affected at all by the slope of the roof. This dimension here, which I'll call dimension A, is affected by the slope of the roof. To find A, we could just do a triangle with 30 inches here. Use the slope to find the rise here and do A squared plus B squared equals C squared. But I'm going to find a slope correction factor, just because we'll use that in a couple of other things. So our slope correction factor is found off of that 612 slope. And what we find is we find this length here, which will be the square root of 6 squared plus 12 squared. Giving us 13.416 inches for that. The slope correction factor is taking that divided by the 12 inches of run. I divide that by 12, gives me 1.118. That is my slope correction factor. So what that means is anything that we know what distance it would be on the flat surface, it's multiplied by that because it gets elongated as we go down the slope. So A is going to be that 30 inches times that 1.118 slope correction factor. So that dimension gets stretched out to 33.54 inches. For dimension A. 33.54 is 33 and 9/16 basically. 9/16 would be 33.5625, so that's about as close as you're going to come to that. Okay, then, let's take a look at what the area of this overall roof is. I'm going to look at this triangle here. That's 36, so half of it is going to be 18. I want to find that height on a 612 slope, so 6 over 12 equals h over 18. Cross multiply and divide gives us h is 9 feet. So then this slant here is the square root of 18 squared plus 9 squared. Giving us 20.125 feet. So the area of that whole roof is that 20.125 times the 44, and then times 2 because there's two sides to the roof. So 1771 square feet is the area of the whole roof. But we do have to correct for the area that chimney takes out. So we find the area of that circle with a radius of 15 inches, a diameter of 30, so it's pi times 15 squared. 0.14 times 15 squared. 706.15, or 0.5, I should say, not 1.5. This is square inches. And I have to multiply that by that 1.118 slope correction factor. Because that would be the 706.5 square inches would be the area on a flat surface. It gets elongated and enlarged down the slope, so it's 789.87 square inches. Now we have to turn that back into square feet by dividing by 144, giving us 5.49 square feet. So we subtract that 5.49 square feet from our total roof area, giving us 1,765.51 square feet of roof area. Now, we're asked to find lateral area of the chimney and the volume of the chimney. To do that, we need to first find the short side of the chimney. We know the long side is 10 feet. We're going to look at this triangle here. This is 30 inches on a 6/12 slope. So 6 over 12 equals, I'm going to call this piece here x over 30. Cross multiply and divide. X is 15 inches. 15 inches subtracted from 10 feet is 8 feet 9 inches, or 8.75 feet. So that height on the short end is 8'9" or 8.75 feet. Either way would be acceptable. Now to find our volume of the chimney, we need the area of the base. We already found that up here. 706. We want the flat base, not the elongated base for the surface. 706.05, or not 05, 706.5 square inches. But we do have to divide that by 144 to make it square feet. That's 4.91 square feet. And we just multiply the area of the base by the average height. The average height here is going to be the 10 plus the 8.75 divided by 2. So 10 plus 8.75 is 18.75 divided by 2 is 9.375 feet. So we multiply the area of that base times that average height. You get a volume of 46.03 cubic feet. For lateral area, we find the circumference of the base, or the perimeter of the base. That's going to be pi times the diameter now. Now the diameter 30 inches, I'm actually going to rate that as 2.5 feet. 30 divided by 12 is 2.5. So pi times 2.5 is 7.85 feet, is the perimeter of the base. And once again, that lateral area is the perimeter of the base, 7.85 feet, times that average height of 9.375 feet. Here's lateral area of 73.59 square feet of area. Well, we just will tackle the big one. It's sitting out there staring at me, so just we'll get it over with. $12, $4 and $20. And the ridge is 88 feet. So for this piece here, we're asked to find the roof area, wall area, volume, and of course the radius of the circle. We have to have the radius of the circle to do much of anything. So let's do that first. So this is 20 feet here. I'm going to cut this into two pieces that are each 32 feet, half of the 64. This will be X here. 32 times 32 is going to equal 20 times X. So 32 times 32 divided by 20 gives us X is 51.2 feet. So that gives us that our diameter is 71.2 feet and our radius is 35.6 feet. Couldn't have made it nice and made that a whole number for you. Sorry about that. So 35.6 feet is the radius of our circle, which means when we extend this down, actually I'm going to draw it differently so that I can extend it down. Okay. So let's do this. It's already 20 feet, so to get to 35.6, we have to come down here 15.6 feet. So the center of this comes straight down, although this is going to get extended out to here. This now becomes that 35.6. From here all the way out, though, is still just the 32 plus 8, so that's still just 40 feet here. I'm going to connect this up here. That's going to be a radius of that circle, which is just the 35.6. And then I'm going to cut this across here to make a triangle, with, of course, this right angle here. This length across there will be the square root of 40 squared plus, I have to add these two together to get 25.6, so 25.6 squared. Giving us 47.49 feet across here. This angle here is just going to be the inverse tangent of the opposite side, which is the 25.6, over that adjacent side of 40. Inverse tangent. Gotta get my second in. Which is 32.62 degrees. So now I have every part of that triangle. This one up here, of course, is going to be 57.38. I just have to subtract my 90 and my 32.62 from 180. I now can find this whole angle up here so that I can find this piece. That whole angle, remember, is found by dividing it up into a 90 degree, and then this piece here from that 312 slope. That angle will be the inverse tangent of the 312 slope. Should be 14.04, I believe. And it is 14.04 degrees, which makes the whole angle 104.04 degrees. Subtracting the 57.38 gives us 46.66 degrees here. So we now have two sides and an angle. We can find everything else in this triangle now. Let's find this angle up here. We know it is obtuse. So I'm just going to call that angle A for right now. I know that 35.6 over the sine of 46.6 degrees. That's this side over its opposite angle. Has to equal this side over that opposite angle, sine of that opposite angle. So 47.49 over the sine of angle A. Cross multiply and divide. Sine 46.6 times 47.49 divided by 35.6. Is 0.9692. Remember, that is the sine of this. We have to do an inverse sine. You get 75.75. That is still not A. We have to do 180 degrees minus that. You get 104.25 degrees, which is angle A there. So this angle up here is 104.25 degrees. Which leaves us then with this angle here being 28.26 degrees. So we now have every piece. Oh, we should find this part up here. I'll call this piece Y up there of that triangle. So it's going to be the 35.6 over the sine of 46.6 degrees equals Y, that missing side, over the sine of my 28.26 degrees. And I'll cross multiply and divide. 35.6 times sine 28.26, make sure we close that parentheses, divided by the sine of 46.6, gives us 23.20 feet. So this is 23.20 feet. I'm going to need that length later when I do my roof area. That's going to be an important length to us. Finally, I need this angle. I'm actually going to do this. I'm going to draw this in here first, and I'm going to find this angle, which will be the inverse tangent of the 15.6 over the 32. Giving us 25.99 degrees. So this here is 25.99 degrees, which means this angle right here is 180 minus that 25.99 minus this 28.26 and minus this 32.62. Leaving us with 93.13 degrees here. So what I'm going to do now, I have all the information I need to find both the area of this piece and the part that contributes to the roof area. Let's find the area of this portion right now. To do that, I'm going to find the total area of this. This piece here is piece 1, that's 40 by 25.6 divided by 2 because it is a triangle, which comes up to 512, I believe. Is that right? Nope, that's not. Yeah, that's right. I'll do it just to. It is 512 square feet. Next, we have this piece here, piece 2, which will be 35.6 times 47.49 times the sine of 28.26 degrees divided by 2. It was 400.24 square feet for that. And our final piece we need is this sector of a circle there. That'll be pi times that 35.6 feet squared times that angle of, what was it, 93.13 over 360. Give us 1,029.48 square feet. So we add those three up. Get 1,941.72 square feet. But remember, we've got to subtract out a couple pieces. We have this piece here that was 40 by 15.6. Forty by 15.6, I believe, is 624. So we'll subtract that out. And then we have this triangle over here that's 32 by 15.6. Now that's a triangle, so it's divided by 2. Give us 249.6. That needs to be subtracted out. They're given 1,068.12 square feet. Now this is going to apply to the wall area and to our volume. So let's do wall area first. For wall area, we know we have two of those. 1,068.12 times 2 is 2,136 times 0.24. There's two of those because there's a wall here. That's this and this. And there's one on the other end that's exactly the same. We have to add in this 10 by 20 wall over here. Of course, 10 by 20, 200 square feet. We add that in to get 2,336.24 square feet of our total wall area. So there's part of our problem. We actually have half of it done. We got the radius and we got the wall area. Let's now look at the contribution to the roof area from this. To do that, we need to know the length of this arc here which is going to be pi times diameter, which would be the 71.8, times that angle, 93.13 over 360. .71.2, sorry, not 71.8. Give us a length there of 57.84 feet. So 57.84 plus our 23.20 will give us 81.04 feet times the length of that portion is 20 feet. So what we found is if I cut out this section of the roof here, this total length is that 80.04 and it's 20 feet in this direction. .04 times 20 is a 1620.8 square feet. We're going to save that. We will add to that later. We'll find the contribution to the volume of this. Contribution to the volume is that 1,068.12 square feet. Also times that 20 feet. I'm giving us 2,136.24 cubic feet. Oops, sorry. 21,361 or 62.4. Put my decimal in the wrong spot. Now we need to go back to just the regular portion of this, the regular roof, without the lean-to. This piece here, we already know that the radius of our circle is 35.6 feet. If this piece is 20, this piece here is the 15.6. This piece is 32. This angle here will be the inverse tangent of 32 over 15.6. Give us 64.01. Doubling that gives us that this is 128.02 degrees. So we'll find the area of the sector. Pi times the radius, 34.6 squared, times that angle of 128.02 over 360. $1415.16. That's going to be square feet. Next, we need to subtract out this triangle, which is going to be 64 feet all the way across, times 15.6 divided by 2. Giving us 499.2 square feet. And we subtract to get the area of that segment. Get 915.96 square feet. Let's do that contribution to the volume. Got 915.96 square feet. Now the total length of this was 88 feet. Come on now. It was 88 feet, but we took out 20 for this portion here. So this part only goes for 66 feet. Sorry, 68 feet, I should say. The 915.96 times 68 gives us 62,285.28 cubic feet. So we add that up to get a total volume. $83,647.68 cubic feet is the volume. Now let's find the contribution of this piece to the roof area. To do that, I need that arc length. That's pi times the diameter of 71.2 times that 128.02 over 360. Giving us a length of 79.50 feet. So that's going to be 79.5 feet times that run of 68 feet. Giving us 5,406 square feet. We add those up. It's 7,026.8 square feet of roof area. Loads of fun. Okay, so there's still one more problem I want to go over. We'll do that on Thursday. There are 3 problems on here that I am not going to do with you. One of them, as I mentioned, was problem number 1. And that's because we've done this on both a worksheet and on a quiz. This is 66 degrees, 58 feet, 40 feet, 30, and 28. I will give you a reminder of how to do this. So you're going to cut it across here. I'm going to call this length X. You're going to find X using law of cosine. Because we have 2 sides and the angle in between them. X squared is simply going to be 40 squared plus 58 squared minus 2 times 40 times 58 times the cosine of 66 degrees. And remember, get X, you've got to come back and square root that. Once you have X, you can find the area of this triangle here. Oops. I wanted to circle that. Come on. You can find the area of this triangle, triangle 1, simply by doing the A times B times sine of angle C over 2 to get the area. For triangle 2 here, got to use Hero's formula. That's where you find the perimeter, then the semi-perimeter, and whatever. And just add those 2 areas together when you're all done. I'll label this for you. Even those are sides A and B, and this, of course, is angle C. The other one I'm not going to help you with is problem number 2. Problem number 2, the area for a regular polygon the area is n times L squared over 4 times the tangent of 180 degrees over n. So for this figure, n equals 8 because there's 8 sides, and L equals 10 because it's 10 feet on a side. Plug those numbers into the formula, it should find your area for you. And the final one that I'm not going to do for you is number 32. Number 32. I did number these by problem, not by answer, not by problem. So number 32, the coordinates. Remember, this is where you take those coordinates, -4, 2, and you put them down in order. 8, -5, 9, 6, 5, 5, 0, 9. And you got to make sure you repeat the first point at the bottom. So this one goes first, and you have to put it at the bottom. And this is where you do those diagonal products that we looked at a couple weeks ago. And of course, do the diagonal products this way. You subtract them and divide by 2. So with that, we do have about 40 minutes left here of class. I'll let you guys have that last 40 minutes to work on your test. Hopefully you found what we covered in class here today to be helpful for you. I'll be on the network for a while if you have any questions. Otherwise, we'll see you all on Thursday.